This is going to be our last video from Chapter 8, looking at sections 8.3 and 8.4, types of chemical equations and heat in chemical reactions. We've now worked on balancing different chemical equations. We are now going to talk about how they're classified, and these are the four main that you're going to need to be able to identify based on structure. So we have a combination, decomposition, single displacement, and double displacement. Let's first start with combination. So we can see combination reactions are when two reactants combine to give a single product. And we can have our A or B here be elements or compounds, but A and B is going to represent a compound. So in our example, we can see we'd have a metal and a non-metal, giving us one compound, which is salt. We could see we'd have a metal oxide and water, giving us a metal hydroxide. In this last example, we can have two different elements combining together to give one compound. And so again, you don't need to memorize any of these specific equations. You just need to have a general idea of what a combination reaction looks like. And in this case, we know that it needs to be two elements or compounds creating one compound. Our decomposition is the exact opposite of a combination. Here we're seeing an AB or a compound break down into two or more products. So here we have a lead oxide breaking down into a smaller lead oxide, decomposing, and an oxygen gas. We also can see the same reaction with carbonates, and often you're going to see your B in these examples B gases. So we have oxygen in the first one, carbon dioxide in the second, and oxygen again in the last one. So again, decompositions are going to be one or small single reactants breaking down into two or more smaller products. Our single displacement is when we have one element reacts with a compound and replaces one of the elements in the compound, giving our other element B plus a different compound. Or we can see A plus BC gives us C plus AB. So in our example, we can see zinc with hydrochloric acid yielding zinc chloride plus hydrogen gas. So our hydrogen has been kicked off and replaced with zinc. And you actually can see this reaction happening in the bottom right. And we'll also do this reaction in lab. Let's look at some other examples of single displacement. Here we have a metal and another acid, giving us again our salt and our hydrogen gas. Here we can see metal and water, giving us our hydrogen and our metal hydroxide or oxide. And our last one, we'd have a metal plus a salt, gives us a metal and a new salt. So in this last one is probably the most clear. We're starting with iron and copper sulfate. That reaction yields copper plus iron sulfate. And again, you can see the same pattern here with chlorine and iodine being replaced or displaced. So our iodine is going to be displaced by our chlorine. And keep in mind, we all need to have these properly balanced with the correct coefficients. Our last reaction is going to be known as a double displacement, where it's looking exactly like a single displacement, only it's happening twice. So we're left with AB plus CD yields AD plus CB. These are the three examples or ways we can look at identifying a reaction, and we'll talk more about these three processes in lab. For now, what you need to be able to identify the differences between these types. So you can see here we have a lead nitrate, potassium iodide, giving us lead iodide and potassium nitrate. So this is also known as a partner switch. Some more examples of our double displacements. Here on the top one, we have our acids and bases combining to give us a salt and water. And so again, here you want to be able to identify that we're having our hydrogen and our OH combining to give us water. That formula sometimes can trick people up, but we're having an H from HCl and the OH from NaOH, giving us H2O. Other reactions, like we said, we mentioned that there are ways we can identify a reaction taking place. Insoluble products can form, and also gases can result as a product of a reaction. And again, we'll talk more about these examples in lab, but for now, be comfortable being able to recognize which of our four types of reaction is. So you need to classify an example. The last thing this chapter is talking about is the heat of a reaction. So are we going to need heat or release heat as a product? And so the first example would be an exothermic reaction where heat is being released as a product. The alternate version of this would be an endothermic reaction where we're absorbing heat and heat is treated as a reactant. So remember the difference that we're going to have exo being released. Exo means outside, endo means within. So endothermic means to absorb it. And so we can look at our heat of reactioning being the amount of heat actually produced during a chemical reaction. And we'll talk more about these in chapter 9. But if we look at this equation, we have carbon plus oxygen yields carbon dioxide plus 393 kilojoules of heat are released. So in this question, in the reaction hydrogen gas plus iodine plus 12.6 kilojoules yields 2 moles of hydrogen iodide. When 4 moles are produced, what are we going to have? We're going to have double of our energy absorbed so the reaction can take place. So here we're multiplying our 12.6 times 2 are going to be needed to produce our 4 moles. And that is it for chapter 8.